Hello all, this is Lokesh, Assistant Professor from the Department of E&D, PSCE, Mandya. Today we shall discuss about the construction of three-phase induction motors. Basically, three-phase induction motor has two main parts. One is stator, which is stationary part of the machine, and other one is rotor, which is rotating part of the machine. Rotor is separated from the stator by a small air gap, which is about 0.4 mm to 4 mm. Now let's move on to the constructional details of stator part of the induction motor. This is the view of stator part of an induction motor. Stator consists of steel frame which encloses hollow cylindrical core, generally made by thin laminations of silicon steel. The reason why we use silicon steel material is that it reduces hysteresis and eddy current losses. The inner periphery of the stator provided with number of evenly spaced slots. The insulated conductors are placed inside the slots and they are connected in a suitable manner such that they form three-phase star or delta connected circuit. The three-phase winding is wound for definite number of poles that depends upon the speed of the machine. That means the speed of the machine is always depends upon number of poles. Greater the number of poles, lesser is the speed, and vice versa. When the three-phase windings are supplied by three-phase supply, the stator produces rotating magnetic field which rotates round the stator at synchronous speed, which is denoted by capital N suffix small s. Now let's move on to rotor part of induction motor. Rotor is mounted on the shaft of the machine. There are two types of rotors available in case of three-phase induction motor. One is squirrel cage rotor and other one is wound rotor, which is also called slip ring type rotor. This is the view of squirrel cage rotor. It consists of cylindrical laminated core. The outer periphery is provided with parallel slots. One copper or aluminum bar is placed in each slot. All these bars are joined at each end by means of metal rings, which are called end rings. So this forms permanently short-circuited winding. The entire construction resembles a squirrel cage. Hence, this type of rotor is called squirrel cage type rotor. The induction motor which employ squirrel cage type rotor is called squirrel cage induction motor. Most of the three-phase induction motors use squirrel cage type rotor because of its simple construction and robust nature. Also, it suffers from a drawback, that is low starting torque. So this is about squirrel cage type rotor. Now let's move on to the wound rotor or slip ring rotor. It consists of a laminated cylindrical core and carries a three-phase winding similar to the one on the stator side. The rotor winding is uniformly distributed in the slots which are provided on the periphery, and usually the windings are star connected. The open ends of the windings are brought out and joined to three insulated slip rings. So these are the slip rings which are mounted on the shaft of the machine. Along with this, three brushes are also rest on the slip rings. The three brushes are connected to three-phase star connected rheostat. So here three brushes can be connected to three-phase rheostat. That means we can include external resistance to the rotor circuit by the use of three-phase rheostat. So it is to develop large starting torque during starting only. Once the motor runs up to its speed, that means once the motor reaches to its normal speed, the external resistances gradually reduces to zero, and afterwards this rotor will also work as squirrel cage type rotor. So the provision of addition of external resistance to the rotor circuit is available only in the case of slip ring type rotor. So therefore it develops high starting torque. So it is mostly used in the applications where the applications demand high starting torque. So this is about details of slip ring type rotor. So now let us go to the operation of three-phase induction motor. So far we have discussed about constructional details of three-phase induction motor. Now let us understand the operation of or working of three-phase induction motor. Basically, three-phase induction motor works on the principle of electromagnetic induction. So this figure shows a part of or a portion of three-phase induction motor. This part represents stator and this part represents rotor side, and this is the air gap between stator and rotor. These are the rotor conductors. So now let us understand its operation. When a three-phase induction motor is supplied by three-phase supply, the stator of the induction motor produces rotating magnetic field which rotates round the stator at synchronous speed. Let us assume that the direction of rotation of stator field is anti-clockwise. So now this rotating magnetic field passes through the air gap and cuts the rotor conductors. So this rotating magnetic field passes through the air gap and cuts all rotor conductors. Now there exists a situation that a relative motion between the stationary rotor conductors and rotating magnetic field. So there is a situation that rotating magnetic field is rotating around the stator, whereas rotor conductors are yet stationary. So due to this relative motion, an EMF is developed in the rotor conductors. Since the rotor circuit is completely closed circuit or a permanently short circuited winding, so therefore the induced EMF in the rotor conductors cause current to flow through the entire rotor winding. So now there is a situation that these conductors are carrying current, whereas the magnetic field is continuously rotating. So therefore here this rotor conductors are under magnetic field which is produced by stator. So therefore the rotor conductors experience mechanical force. The force due to all conductors, the force due to all rotor conductors add up together, and hence they produce driving torque. Once driving torque is produced, the rotor tends to rotate. Always the rotor rotates in the same direction as that of the rotation of stator or magnetic field. So this phenomenon can be explained by using Lenz's law. So therefore rotor starts rotating in the same direction as that of the rotating magnetic field. So this is how a three-phase induction motor works. Thank you.